In this lesson, we're going to start our discussion about polygons. If we look at the word polygon, we notice that the first part has poly. Whenever you see the word poly, it just simply means many. You might not often see gon, but it means angles. So if you already knew gon is angles, then right from here you know that a polygon has got many angles. However, we work with this definition of a polygon being a plane figure that has more than 3 straight sides and 3 angles. From this definition, it's like we're saying quadrilaterals are part of polygons. However, mostly quadrilaterals are not talked of being polygons. They are just talked of as quadrilaterals. Instead, we talk about polygons being shapes or plane figures that are from 5 sides to 10 sides. Examples are shown on screen, but it's very important to not only know that this is a 5-sided polygon, 6-sided, 7, and so on. There's a special way in which we name polygons. We'll have polygons ranging from 5 to 10, and then we'll have the names that are given to these polygons. When you hear the word pentagon, pent means 5. So if you see we're still using gon for each of the names, and then the first parts are going to tell us how many sides it has. For a 6-sided, we use the first part hex. Hexagon is the name of a 6-sided. For 7, we have sept and hept. Each of the two will mean the same, but mostly you find that heptagon is used oftenly compared to septagon. An 8-sided polygon is referred to as an octagon. I'm sure this is why we've heard of an octopus. A 9-sided is a nonagon, and finally a 10-sided is a decagon. The parts of a polygon are very important to know. There are not many. Of course, we have the sides, side AB, BC, CD, DE, and EF. Actually, we also have AF. These are sides. We know that they are sides. We won't talk much about that. What I want to really emphasize here is an internal angle and an external angle. I want you to notice the differences between these two angles. I'm going to start with discussing about the internal angle. If you look at the internal angle, this is the angle between two sides of a particular polygon. Here we've got a hexagon, so the internal angle there can be the angle between AB and AF, which can be named BAF or FAB. When we're drawing polygons that are regular, the internal angle is always the same. So the angle BAF, BCD, FED, or simply all the internal angles here in this hexagon are going to be a particular value. If any one of them changes, that polygon would no longer be a regular polygon. The next thing you need to know is that the external angle is the angle between a particular side of a polygon. For example, here we have side AF and an extension of one of the sides of the polygon. Here we've extended side AB. As you saw from the animation at first, there was an extension. That is an external angle. The realization that an external angle is always between a side and the extension of another side is very key. The angle that will be from AF up to FE in this direction like this is not the external angle of this particular polygon. Why? Because we've used two sides. It's not even the internal angle because it's not kind of inside this polygon. Those two parts are very important. You hear me referring to the internal angle or the external angle. in other parts of the lessons about polygons. Next is knowing and understanding some important distances. The first distance we need to know about is the side length. Very simple, but very key. Whenever you hear in questions or when you read in a particular questions where they say the side is 55 millimeters, they're referring to side length. Usually you'll be given the base side length. For example, here AB, you'll be told side AB is 55 millimeters, or they'll just tell you a hexagon has a side of 50 millimeters, and then you'll be required to construct that hexagon. Next is the distance across flats. When we talk about flats, you can just think of them as sides. AB is a flat, DE is a flat, BC is a flat, and FE is a flat. So the distance across sides is what they're talking about when they say distance across flats. Now, I would like you to kind of understand what's happening here a bit. The distance across flats can be measured like this, or like this, or even like that. Now, what guides us to know that all these three distances are distances across flats? The binding principle in getting your distance across flats is that you should always get the perpendicular distance between sides of a polygon that are opposite each other. The key to knowing that these two sides are opposite each other is just checking if those two sides that you picked are parallel to each other. For example, here we've got side AF. You can see this is side AF here. You notice side AF is parallel to side CD. So if we measure the distance, the perpendicular distance between AF and CD, will be measuring the distance across flats. This distance is very key when we're drawing boats in engineering drawing. Next, we need to know the distance across corners. A corner here just referring to a particular point on a polygon where two sides have a common point. For example, A, B, C, D, E, and F. Or simply a vertex of a polygon. The distance across corners might be kind of confusing at first to really notice or picture, but as you see more of distances across corners, you easily begin to visualize the concept. What you must look for is some two vertices that are opposite each other, for example F and C. Then you measure the distance between them. That will be the distance across corners. When you're about to measure your distance across corners, apart from noticing that the vertices you've selected are actually opposite each other, it's a good idea that you check for this. You should check for symmetry. By symmetry, I mean that what is going to be above that line that you selected to measure your distance across corners should be the same as what is below. For example, here if we draw a line from F to C and then we measure FC, if truly the distance FC is the distance across corners, we expect that the shape FEDC is the same as the shape FABC. Additionally, what you must remember is that distance across corners is usually a distance that is found in polygons that have got even numbers. For example, a 6-sided, 8-sided, 10-sided. It's very rare that you find the terminology of distance across corners for odd numbered polygons. For example, a 7-sided or a 9-sided. With this information discussed, we are now ready to start drawing the various kinds of polygons using the various kinds of methods that we have. Hope you enjoy. There are many methods that we're going to look at for polygons.